Hello, abstract algebra students. We will now begin the proof that matrix multiplication is well defined on M2R. So what we want to show is the definition of well defined applied to the elements as matrices, the set M2R, and the operation matrix multiplication. So what this is for all A, B, Y, Z in M2R, if both A equals Y and B equals Z, then A times B is equal to Y times Z. So let's let A, B, Y, Z and M2R be given. Now, just like with associative, we need to actually assign these to be real matrices. So without loss of generality, we may assume that. And here's where we will make assumptions about what the most general matrices A, B, Y, and Z are. So A and B will take going from the beginning of alphabet. So A is the matrix, A, B, C, D. B is the matrix, E, F, G, H. Now, Y is going to be the matrix and Z is going to be the matrix that we get working backwards from the end of the alphabet. So Z is going to be the matrix WXYZ, and Y is going to be the matrix STUV. Now, this was an extra thing that we had to do before we unpacked our if-then statement. Because we knew we were dealing with matrices, so we had to actually make A, B, C, and D look like, well, matrices. But we had to have letters here as their entries rather than numbers. Otherwise, we would be losing generality and thus no longer eligible to prove something with a for all quantifier. Now we are ready to work the if-then statement. So we'll assume the if part, assume that both A equals Y and B equals Z. Now, I am going to go as far as I can thinking forwards, trying to push each new assumption one step further. So, since we know that both A equals Y and B equals Z, by the definition matrix equality, it follows that. And I'm just going to set all the pairs of entries equal to each other. So there are going to be a lot of them. One, two, three, four, five, six, seven, eight. So we know from A equals Y, we know that A equals S. We know that B equals T. We know that C equals U. We know that D equals V. We know that E equals W. We know that F equals X. We know that G equals Y. And we know that H equals Z. Okay. Now, I really don't see what I want to do next. So, as often is the case when I'm proving an if-then statement, if I don't see what I want to do next, I'm going to come down here to the scrap paper, and I'm going to reason backwards from what I want to show. So, I want to show here that A times B equals Y times Z. That means that I want to show that the matrix A, B, C, D times E, F, G, H equals the matrix STUV times the matrix WXYZ if I multiply this out, what this means that I want to show is the matrix AE plus BG, and then CE plus DG, then AF plus BH, and then CF plus DH equals the matrix SW plus TY, UW plus VY, SX plus TZ, UX plus VZ. Now, in order to show this, I have to show the four corresponding entries are equal to each other. So, to show this, I need to show that AE plus BG equals SW plus EY. I need to show that AF plus BH equals SX plus EZ. I need to show that CE plus DG equals UW plus VY. And I need to show that CF plus DH equals UX plus VZ. Now, that doesn't look like I've gotten anywhere. But I know statements about various pairs of numbers being equal, and I need to build up that these four expressions are equal. So the way that I'm going to do this is I'm going to try to build each expression out of these pairs. For example, the fact that A equals S and E equals W gives me that AE equals SW. The fact that b equals t and g equals y gives me bg equals ty from the fact that multiplication is well defined. So you see, I'm going to use the multiplication as well defined, ordinary multiplication, to get various products of numbers that are equal. And then I'm going to use the fact that addition is well defined to get various sums of products that are equal, to build up the all of these entries are equal. I will do that on the next video. Sadly, YouTube limits the length of videos to somewhere in between 12 or 13 minutes. That is actually not bad because I think sometimes attention spans also tend to be limited in that range as well. So I will continue this on the next video. Stay tuned.